Friends, it is another great day to be talking water and wastewater, and whether it's your first time tuning in or you listen and watch every single day, thank you for spending your time here with us. This is the Water Online Show, powered by Water Online, the leading online destination for the water wastewater market. I am your host, Travis Kennedy, and joining me as usual is my co-host, chief editor, and Mr. Tell It Like It Is, Kevin Westerling.
That's me.
That's up, you. Travis? Hey, we made it. We made it to another year.
Yes,
so
we did.
We are on to season 2 of the Water Online Show. We have a brand new studio, as you can kind of see from the background here. So it's an exciting time here at the Water Online Show.
It is.
And you know, as we head into this new year, we all have a tendency to look back. That happens a lot. Looking back gives us some perspective on what we spent our time on, what we spent our very limited at times attention spans on, and perhaps most importantly, what problems arose and how did we fix them. That happens as we go into this part of any year. But in this past year has been no different. And we here at the Water Online Show have tried our best to cover almost every topic that we could that was pertinent to you out there, our listeners. But at the same time, with everything else in life, when there's a new mentality, when something comes along where it's just like we need to spend time talking about A, B, C, and this and that. I mean, that could be, anything from PFAS to BABA to lead or copper rule, all those types of things. Whenever you do that, something inevitably gets left behind, either a topic or a problem or a situation that certainly deserves real estate in the discussion. So, to put it in water wastewater terms, some problems continue to need to be addressed, no matter what year it is or where we are in that year. One of those is nutrient removal. And I know what you're saying. You're saying, oh, Travis, PFAS is a bigger issue. There needs to be more focus on LCRI or BABA or whatever the case is. But look, we can chew gum and walk at the exact same time. Nutrient removal is still a common issue that most engineers and operators in the space are dealing with and, quite frankly, will continue to deal with. So here to help us shed some light on that topic specifically as we head down the 2025 road is a very special guest, none other than Jose Jimenez, Vice President of Wastewater Treatment at Brown and Caldwell. Jose, welcome to season 2, episode 1 of the Water Online Show.
Good to have you.
Yeah, thank you. I'm really happy to be here. And yeah, happy holidays, guys.
Happy
it's a great
holidays
topic.
To you as well. Now, nutrient removal was a huge talking point a couple years back and even further beyond. I remember discussing it at length whenever given the opportunity, because it is and was a really big issue and still is today. But it's been overshadowed more recently by things like PFAS or lead or insert any topic that you want to in there. But there have been other topics that have sort of taken priority in terms of discussion. But we want to refocus, take the lens back and look at what this problem is and how it's still affecting us. So, because it really hasn't gone away. Could you talk a little bit about the scope of the problem and the challenge it represents for municipalities right now?
Yeah, of course, nutrient removal remains a significant challenge for municipalities, despite being overshadowed by issues like PFAS and lead, as you mentioned. Excess nutrients, of course, mainly nitrogen and phosphorus, either they're coming from agricultural runoff, wastewater discharges to stormwater, continuing to fuel harmful algal blooms, dead zones, water quality degradation in lakes and rivers. I live in Florida, so we actually face those issues pretty much daily. And of course, addressing this problem requires a unique upgrades to the wastewater treatment plants that sometimes could be challenging for municipalities, could be costly. I do think, as you mentioned, we can walk and chew gum at the same time. I think the key point for this challenge lies in balancing the environmental protection with economic feasibility while addressing not only nutrients, but also these emerging contaminants like PFAS. Trying to find that balance will help utilities meet their ultimate goal into pretty much providing a health environment for us to enjoy.
Balancing is the key to running any efficient municipality, that's for sure.
Certainly. Mm-hmm. And in terms of nutrient loads and the resulting harmful algal blooms, are these areas typically restricted to certain areas and seasons? And for those that do experience these issues, is there work? I know, the blooms are going to show up in warmer waters, warmer weather, but is there work to be done in the colder months to prepare yourself for those seasonal warm weather algal blooms?
Yeah, of course, nutrient removal issues are not restricted to any specific area or season. But of course, they're more pronounced in regions with high nutrient loads and water bodies that are prone to eutrophication. That's the overarching goal. Of course, we understand that in colder climates, wastewater treatment plants face challenges maintaining nutrient removal efficiency during winter because, of course, lower temperature means lower biological activity.
Mm-hmm.
However, despite the seasonality of these natures, of course, we have to make sure that we remove nutrients all the time, everywhere, to make sure that we protect these water bodies. Despite the seasonal nature, of course, of algal bloom, we need to make sure that the work in colder months it's done, because we don't want to accumulate, we don't want to build up these nutrients in the water bodies that could fuel algal blooms during warmer months. Of course, I live in Florida. We don't have that issue. We have to do nutrient removal all the time because it's warm. But of course, we do have to maintain actions and maintain efficiency of the treatment process to reduce the nutrient discharges into the water bodies, whether it's winter or month or summer conditions.
I know that algal blooms has been a topic. Nutrient removal has been a topic that we've covered at length throughout the years, decades, however long it's been that they've been addressed. One thing I'm curious about is, as it stands right now on the precipice of this new year, have algal blooms gotten worse? And if not, great. But if so, why?
Yeah, I think, of course, living here in Florida, we do experience algal blooms pretty much daily, those issues. So my answer is yes. Algal blooms have worsened in recent years due to a combination of factors. Of course, increased nutrient pollution, whether it's from wastewater treatment plants or from agricultural runoff, could be one of the issues, and that continues to fuel the growth of these harmful algal blooms in the water bodies. Climate change, we talk about climate change and we don't relate it too much to algal bloom, but climate change exacerbates the issue by warming the water temperatures, which creates a favorable condition for algae. And then, of course, intensifying rainfall. Again, I live in Florida and it rains every day in the summer, which means that we're transporting more nutrients into the water bodies, and therefore we are creating these conditions for algal bloom to be worse. Of course, urbanization, deforestation, inadequate wastewater management, all these factors have to be taken into account when we look at it. And of course, and these factors have led to more frequent and severe widespread algal blooms issues in Florida and all the coastal areas and the water bodies in general.
Right. And of course, we have point sources and non-point sources for nutrients, like the non-points being agriculture and stuff like that. But as far as the wastewater treatment plants, who, the regulatory agencies try to get control of this through nutrient limits, but each one, how do they set the nutrient limits per wastewater treatment plant? And how low are they actually going to where, we need these technologies to get down to those numbers?
Yeah, this is a great question. And this is one that I'm often not asked because I'm not a nutrient limit expert. But of course, we know that nutrient limits are regulatory threshold or boundaries designed to control the amount of nitrogen and phosphorus in the case of nutrients entering any specific water body. They're typically set based on scientific studies assessing how much nutrient load in a specific ecosystem can handle without degradation. The limits are tailored to the characteristics of the designated area, water use, drinking water standard, aquatic life, and so on. So that's how they're set. When we talk about nutrient removal, especially or specifically, and how low the limits go, we of course know, for example, for phosphorus, the limits can go as low as 0.01 milligrams per liter in sensitive areas, very low numbers. When it comes to nitrogen, it's a little bit different. But with what we call limits of technology, it's about 3 milligrams per liter total nitrogen, which is as low as we can go biologically without doing reverse osmosis or any other very expensive treatment. So that's where we are. We are in the sense of 3 milligrams per liter total nitrogen, 0.01 milligrams per liter total phosphorus. But these requirements relies on a significant investment to utilities, not only from capital, but also operational maintenance cost to run them.
I mean, keeping in mind too what we talked about a little earlier in the show about efficiency and balancing and being able to walk and chew gum at the same time. If we're looking through this next question through that lens about efficiency and of course lower limits than perhaps what they would have been a year ago, 5 years ago, 10 years ago. So what are the typical technologies that are available to help treat and do an efficient nutrient removal process at a municipality?
Yeah, the most commonly used technologies for nutrient removal is what we call biological nutrient removal processes, sure. Whether they are suspended growth, biofilm-based technologies, but they are pretty much active or sludge processes coupled with either chemical phosphorus precipitation, tertiary processes for additional denitrification to meet very low effluent requirements for both nitrogen and phosphorus. Of course, there's a lot of research that's currently going, and it's been going for a number of years now, to actually develop newer technology to do what we call intensify the existing technologies, this process intensification term that you might hear all the time in conferences and things like that. And to me, these are technologies that could do more treatment with less resources. And those are the ones that are actually gaining a foothold in the industry because of the benefits that they bring.
Right. And I think we want to get a little deeper into intensification in a bit. And I don't know, are there other ones available when we talk about enhanced nutrient recovery, or you said you can only get so far with BNR? You made reference to reverse osmosis. What are the new and potentially better technologies that we can use to get down to those low limits?
The good stuff, the better stuff.
Yeah, the better. So what gets me excited every day.
Yeah, exactly.
And there are a number of them, of course, and we can bracket them in different families. But to me, the promising technologies to actually address nutrient removal while doing process intensification are, of course, aerobic granular sludge, AGS, membrane aerated biofilm reactors, MABR technologies, mobile organic biofilm or MOBs, side stream biop, partial denitrification animals. There is a family of technologies that can do that. However, since I normally like to look at it from the simplistic lens, there are other technologies that actually are beneficial for clients. And one that I get real excited about, it's using aeration controls to optimize processes. And of course, either using ammonia-based aeration control, low dissolved oxygen concentrations. And the reason why I get excited about it is because these are changes, or these are technologies that could be implemented with very minor modifications to facilities. And no structural modifications, pretty much any facility could go out there and start implementing these technologies very quickly. Of course, depending on the needs and the requirements, these are some of the solutions that could be available for us these days.
Available anywhere. It can work anywhere. That's certainly appealing. Now, I know that when it comes to nutrients, as bad as they might be for our waterways, they're actually really important when we put them in the perspective of our food supply, right? So talk about the importance of nutrient recovery as it works in concert with nutrient removal.
Oh, yeah, this is a topic of interest, and it's a moving target all the time. Nutrient recovery is critical for balancing the need to protect the wastewater from nutrient pollution, but also to supplement the demand for sustainable food production, for example. Nutrients like nitrogen and phosphorus, of course, are essential for crop growth, for agricultural, for the activities related to agriculture. Nutrient recovery technologies, of course, they capture valuable resources from wastewater, and we can convert it into useful fertilizers or byproducts. And that's the beauty of this. The approach not only reduces pollutants from the wastewater, but also creates this circular nutrient economy that supports not only the environmental health when it comes to reducing nutrients to the water bodies, but also to the agricultural productivity. We actually are making sure that we are providing that economy, that circular economy, to benefits not only the waterways but also the users in general.
Resources that we need. I mean, the circular economy. I mean, it's all there, and it all makes a lot of sense. But these are resources that we actually need.
Mm-hmm. Definitely. And so let's get back into the intensification, a word you used a little earlier when you talked about like better ways of removing nutrients. So what is meant by that term for those unfamiliar, and what are the benefits of it? How difficult is it to implement, and is it really fit for anybody, or is this just for certain plants?
It's a loaded question. That's a lot of questions within that.
Oh yeah, loaded question.
Yeah, of course, my definition of process intensification, there are definitions out there, but my definition, the one that I like to use all the time, relates to doing more treatment with less resources. Anytime we do a project and you implement either a technology or some optimizations activity that actually you can do more treatment with less resources, that to me, it's a process intensification project. Of course, I believe that some kind of process intensification could be implemented in any facility, either via, as I said, process intensification, process optimization using, for example, aeration controls, or by adding new technology like pDNA, MABR, MOB, all of those. In terms of the benefits of intensification, I think we can relate this to resources. And when I said resources, I bracket them in different families, but they could be less fixed physical space for treatment. We know because of the rapid urbanization, we don't have enough room to expand facilities anymore. Therefore, the more treatment we do in very small footprint, the better we are. Aeration energy. We know that aeration takes about 60 to 70% of the energy of any wastewater treatment plant. And by implementing this technology, reducing that aeration energy is critical. And of course, and eliminating or reducing chemical dependency. And when I said chemical dependency, these are the external chemicals needed for the treatment. In some cases where we actually do process intensification, we've been able to reduce aeration energy by 50%, about 50%.
Wow, that's a lot.
While eliminating completely chemical needs, meaning acetic acid, methanol, a number of them, while treating more flow. Sure. And that's where I get excited. If we can do like this triple whammy when it comes to technology implementation, do more in less footprint while reducing O&M and better performance, I think that's what gets me excited every day.
Yeah, less footprint, more efficient, and less money, less expenditure, right? Those are three important things that I know are on the top of mind in most municipalities across this great nation. So that is really reassuring to hear that these technologies and these processes can achieve a lot of those things. So if there's a municipality out there that would like to get more information or talk to you more about some of their nutrient either recovery or nutrient removal issues that they have, what's the best way for them to reach out to you?
Well, either via LinkedIn, email, a phone call. I think my information, my contact information is available, so they could reach out directly or through Brown and Caldwell. Again, they know where to find me.
Yeah, well, it's not hard to find Brown and Caldwell. That's for sure, especially in this market. So, Jose Jimenez, thank you very much for spending your time here with us. We can't wait to have you back at some point in the next year or so to get a grasp on how it's going with nutrient removal and what the updates might be. But for now, I want to thank you for spending your time here with us today.
Yeah, thank you. It's been my pleasure.
And for all of you out there, I want to thank you for your time listening or watching. We certainly do appreciate it, and we can't wait to see you back here as we go throughout the entire year with new episodes and a new set that we have here. Kevin, again, I can't believe that we have a new set here to present to broadcast from. We look forward to having you back here, whether it be on Spotify, YouTube, or on wateronline.com. Thank you very much for joining us, and we will see you next time.